Welcome back to the morning show. Joining us this morning to put his own spin on the truth behind spinning is our favorite wise guy, Matt Sellon. Thanks for joining us today.
Oh, it's fun as always. And this time we're going to see if somebody gets dizzy, Robert.
Guess who gets to sit in the chair?
Right. So,
weather guy, scapegoat.
That's right. The question for this week was, how does a figure skater get herself spinning quickly? You know, you see these people out on the ice and they're going very, very fast.
Right.
And how they don't get dizzy is amazing to me, and I don't understand that. But the way they do this, and I got good answers from several people, Mike Reese and Monica Harrison and Carrie Keating, and Mike gets the t-shirt because he's never won before. The way they do this is they pull their arms and their legs very close to their body, and that causes them to spin faster and faster. And that's what we're going to explain today. That's what I want.
I'm not putting on ice skates.
That's okay. You don't have to. You just have to hold some lead weights in your hands.
Okay.
Okay. And the key for understanding this is something called angular momentum. And to understand angular momentum, the first thing we have to do is understand something called rotational inertia. Okay. Now, before, a few weeks ago, we talked about inertia, which was how heavy something was. That determined how hard it was to get it to move.
Right.
Okay. It's the same with rotational inertia. It's hard to get it to spin or hard to get it to stop once it's spinning.
Right.
And a key ingredient in rotational inertia is how far from the rotation axis the mass is located. So if the mass is way out, if your arms are spread out like this and your legs are spread out, you have a big rotational inertia. If you go like this, you have a small rotational inertia. And I can prove this by having you sit on this chair.
Have a seat, Robert.
Even in the first segment, huh?
Yes.
Yeah.
Oh, yes. We have lots of spinning to do here. Okay. So why don't you hold these two bars, but hold them close to your chest. Okay, and lift your feet off the stool, and Gay, why don't you try to spin him and see how hard it is?
You're letting her drive?
Not too hard, right? Oh. Okay, so let's start. Now,
sure.
Stick your legs and your arms way out.
I'll slide off the stool.
That's okay. Now try to spin him. It's harder, isn't it?
Yeah, it is.
Okay, so he has more rotational inertia. Oh, we'll get to this in a minute. You're getting ahead of us here. That's okay.
So he's having too much fun.
He's got more rotational inertia when he's like this than when he's got it in, because it was harder to get him to move.
It was harder to get him to move.
Right.
What if I do this?
We can try that in a minute.
Okay.
Now, the thing that's important is that once you start spinning, let me just get you going this way to unspin you. You want to keep going at the same speed like this, no matter what happens, because angular momentum is conserved. And angular momentum is something that won't change unless there's friction. Now, it is a product of how fast you're spinning times this inertia thing. Okay? So, if you make your inertia bigger, you're going to slow down. If you make your inertia smaller, you're going to speed up, because the product of those two things can't change. So let's do the experiment.
Okay.
Stick your arms and legs way out. You have big rotational inertia. We'll
let me push him. Oh.
We'll give you kind of a small spinning speed. Now pull your arms and legs into your body. You go faster.
Oh, that's cool.
Okay, stick them out again, and you slow down. So the product of how fast you spin times your inertia is a constant. Now you're dizzy, right? You want to go the other way?
Not so much, no.
Does that help him get it? That'll help him be undizzy, won't it?
That's right. Now, if you go the other way, it should help.
Really?
Yeah, yeah.
You thought I was just saying that to spin you.
I'm a doctor. Okay, so stick your hands out, slow, pull them in, you go fast, just like a figure skater. So the figure skater starts out in a spin with her mass far away from her body like this.
Right.
Hold her arms and legs in. That makes her rotational inertia smaller. That means she has to spin faster to make up for that. Very good.
Fun.
Are you dizzy now?
You wanna
No,
try?
that's okay. I'll pass.
Thank you.
And these things are quite heavy. And
Yes.
since the figure skaters really don't weigh that much, I mean, they're little things.
That's right. So, but they tend to be sort of slim, and when they pull their arms and legs close to their body, it's very close.
Yes.
And when they stick them out like this, it's actually, it makes quite a bit of a difference. And so that's why they can get going very, very fast when they spin.
And after doing this, I'm amazed they can spin and then take off skating again.
Yeah, I don't know how they do that either. And in the next part, we're going to have you spinning some more, holding some rotating bike wheels and things like that. And we're going to talk more about this angular momentum stuff, because it's pretty weird.
Sounds like fun.
All right. We're going to push them around some more.
In addition to that, we've got the, on the morning show, we've got the Wish You Were Here segment. We're going to take a short vacation. Stay with us for that.
Also coming up, some products that will give you a double whammy. We'll show you why kitchen gadgets can do more than one function.
I have an excuse. I'm dizzy. What the...
I've been watching you. That makes me dizzy.